Hello, my name is Nianzuk Raymond Long. I understand it's long. Sorry for the bad pun. Anyway, I'm a senior at Sam Houston State University pursuing a geography major under the environmental concentration with a geology minor. I'm also one of the founders for the SHSU VR Club. VR stands for virtual reality, and it's a digital space that can be accessed through a headset, also interacting with the objects within that space through these controllers. We play a lot of VR, but we also work hard on VR projects. Our biggest one so far is partner up with NASA. NASA has this program called the Hunch program where they go out to high schools and colleges to give them a challenge. The one we accepted was the dynamic virtual deep space exploration, where we in virtual reality simulate a donut-shaped spaceship where the outer ring spins, creating centripetal force to simulate artificial gravity, like Space Odyssey.
Hi, my name is Waverly Williams. I'm the current treasurer for the VR Club, and I'm currently a senior at Houston State University. I am also a double major in criminal justice and cybersecurity.
Hello, my name is Christopher Ebner, and I am currently a sophomore pursuing a degree in cybersecurity with a particular interest in penetration testing and RFID systems. As a member of the Virtual Reality Club at Sam Houston State University, I am excited about our dynamic virtual deep space exploration project. This project is intended to aid NASA astronauts and other space enthusiasts in experiencing the future of deep space travel. Our aim is to adequately prepare astronauts for life in their future homes, a space torch designed to simulate Earth's gravity. Long term, our goal is to aid in engineering development of a rotating spacecraft for simulated gravity and long term space travel. Currently, one of the largest hurdles mankind must overcome for extended space travel is a lack of gravity in space. This lack of gravity can cause long term adverse effects on the human body, such as muscular atrophy and bone loss. Due to these effects, astronauts endure many challenges such as difficulty with their balance, trouble walking, changes in eyesight, nausea, and more. Currently, there are no spaceships that can replicate gravity. However, the proposal of a rotating toroid has provided the concept of simulated gravity via centrifugal force, but this is not the same as Earth's gravity and will require specific training. Our virtual reality project will provide for this very necessary training, allowing for users to get a realistic feel for what it is like to be in a rotating torus-shaped spaceship and how different items on the spaceship may behave. In our project's current iteration, we have developed many features.
The features that go into the simulation are data collection and analysis, interactive objects, and multiple scenes. The data collection and analysis we're very thorough of to make sure they match to real world physics to the best of our ability. The physics team include me, Joshua, and Chandler. We do a lot of research on our own, but this is one of my main contributions to this project. As a geography major, there is a physical side, and I have to do some math for it. We then display these datas into scenarios. We have 3 scenarios on the poster. The first scenario is an Earth simulated under normal Coriolis effect. We have to make sure we got our math correct. And then scenario 2 is the same Earth, but we heighten the Coriolis effects by putting it on top of a rotating platform. And then scenario 3, we actually send it to deep space inside a rotating spacecraft. To make it more realistic, we added interactive objects inside. We have ladders that lead from the central core down to the outer ring. We have living quarters with a sink and shower. A gym with a treadmill, barbells, sets of weights, other workout equipment. Several pillows for growing plants, water hose, flying drone. We even have 3 pendulum clocks on the wall at different heights to show the spinning force. And I've been told this is the most important of all. 3 balls for juggling and throwing.
Our visual experience of the space station has a design of an outer torus. This creates the Coriolis effect, which simulates gravity. Another visual experience we have is the experiment room. This room includes a computer, a flying drone, and a ball to test gravity. We also have pendulum clocks on the back wall. These clocks display different time zones from throughout the world. The development frameworks that we have used to create this project are Unity and SteamVR. By creating a rotating torus for deep space exploration, this will allow NASA astronauts to experience what living conditions might consist of farther into space. Another purpose for creating a rotating torus model is to create excitement in the community and interest NASA enthusiasts. Anyone will be able to download our application and take a tour of space through the eyes of our astronauts. The future direction of this project is stitching the scenes together and applying universal shaders throughout the space station. We would then move on to data testing and organization of the project. Afterwards, we would build a modular interview system that rearranges itself according to the parameters of the station. Finally, we would finalize utilities, electricity, and the fluid dynamics. Lastly, we want to give a special thanks to Glenn Johnson and the NASA Hunch Project for supporting us throughout this project.